Hello, and welcome to today's webinar on Farm to Power, Harvesting Renewable Gas from Agricultural Sources, which is hosted by the Rethink Methane Symposium. My name is Cliff Gladstein. I'm the president of Gladstein Anderson Associates, and it's my pleasure to be moderating this panel, Farm to Power. G&A, for those of you who aren't familiar, is a clean transportation and energy consulting firm that specializes in the market development of low-emission and alternative fuel vehicle technologies, infrastructure, and fuels for both on- and off-road applications. We produce the Rethink Methane Symposium, which was created to educate policymakers and stakeholders about renewable methane, how this clean energy resource can help California meet its air quality and climate protection improvement goals, help us recycle and beneficially reuse much of our organic waste streams, provide critical feedstock for the production of renewable hydrogen for tomorrow's hydrogen highway, facilitate the development of renewable power by providing a practical storage medium for both solar and wind energy, all of which will help the state greatly strengthen our economic future. Just this week, we have announced the full agenda and speaker lineup that will be joining us at the June 29th Rethink Methane Symposium at the Sacramento Sheraton. On June 30th, we will also be hosting an off-site tour to the Sacramento Biodigester. Space is limited for both events, so if you haven't already signed up, please visit our website at www.rethinkmethane.org to become a part and a participant. To prepare for the Rethink Methane Symposium, we thought it would be valuable for our audience to learn more about some of the exciting, innovative, and important renewable methane production projects that are occurring right here in California right now. We have invited two of the leaders in this movement to create California's renewable methane economy to share their stories with you today. Joining me are representatives for two agricultural operations that are pioneering renewable gas development. They will be sharing with us their stories, focusing on how their projects were conceived, funded, the technology evaluation and development processes they undertook, the key lessons that they learned, and their future plans. I'd first like to introduce to you Russ Lester. Russ is the co-owner of Dixon Ridge Farms. Dixon Ridge Farms utilizes walnut shells as a feedstock for their own on-site energy production facilities called the Biomax 100 kW systems. This system produces about 1.5 million kilowatt annuals annually, which is worth about $250,000 of avoided electricity costs per year, and it's used to fuel their drying facility, generate electricity, and heat their buildings. Our second presenter is Daryl Moss. Daryl is the president of Moss Energy Works, and they have developed a Lagoon digester on the Van Warmerdam dairy that processes the manure from the milking cows there to power a 600 kW peaking generator. The engine runs during periods of highest demand and sells its power to the Sacramento Municipal Utility District, SMUD, while storing biogas during periods of low demand. Both of these biogas ventures represent the kind of renewable gas projects that will be discussed at the Rethink Methane Symposium on June 30th in Sacramento. The emphasis of the symposium this year is breaking down the economic and regulatory barriers and implementing policies and incentives to encourage the development, the production of renewable gas and its consumption. Before we get started with the presentations, there's a few things to keep in mind. First of all, let's talk about how to submit questions. We, of course, encourage all of our participants to please submit any questions that you have for our speakers by using the question and answer box that you can see located in the lower right-hand corner of your screen. We will be answering as many questions as possible during the Q&A session that will follow the presentations. You can submit questions at any time, and we'll add them to the queue as they come in. Also want to let everybody know that a link to a recording of today's webinar is going to be sent to all of the participants and RSVPs to this webinar. That will happen early next week. Third, at the end of this webinar, we would really appreciate it if you would complete a quick 30-second survey. It's very important for us to tailor our webinars to the needs and interests of our attendees, and so your feedback would be greatly appreciated. Finally, for any technical issues that you may face during the course of this webinar, or if you need any assistance, please contact Grace Jameson. She's our technical guru. You can reach her at grace.jameson, Jameson is spelled Jameson, at Gladstein, GLADSTEIN.org. That's her email address. You could also reach her at 310-570-3463. With all of that being said, let's get started with our webinar. I'm very excited to turn the controls over to Russ, who will be providing us with insight into his operations at the Dixon Ridge Farms. Russ, the floor is yours.
Okay, well, hello everybody. Forgive me, I'm a newbie at this, so hopefully we can actually go forward and I'll make no mistakes. First of all, I have to get my screen up here. Okay, so first of all, who we are. We're a grower and processor of organic walnuts, and we're in Winters, California, which is a little bit east of Davis, California, and Sacramento. We grow walnuts over a number of acres and process a number of walnuts from other growers and many, many acres. We've been farming in California for quite a number of years, but most important part of this slide is that we follow a sustainable whole systems approach to farming, processing, and our business. And part of that is our conservation practices that we've been doing for quite some time, and we've added some things over the year. First of all, we recycle everything, and I'm talking about organic material as well as water, back into the orchard soil as much as we possibly can. And the reason for that is because the more we return, the less that we actually take out, and the less that we have to put back in to make the system stay sustainable. The same thing is true with Holler and stormwater. And I'm going to go off on this a little bit, as I know it doesn't sound like energy, but it is absolutely part of energy, because if we don't have to pump groundwater out and we can keep it in here, then we save energy. And that's part of the entire equation. Same thing is true with the prunings. We've been chipping and putting back in the soil since 1976. We've also really worked a lot in land conservation and preservation. And the main reason for this is that sustainable agriculture, as we practice it, is easier on the best soils, water, and environment. And it's also the best use of a finite and an invaluable resource. We believe strongly in Williamson Act and ag conservation easements for the best tools. And it's important because, you know, the greenhouse gas reduction due to what we're going to talk about in just a minute. We also practice integrated pest management since it really came out, and we do sustainable organic. And by that I mean we use very, very few pesticides, no herbicides, no synthetic fertilizer, and we acknowledge that even organically approved chemicals, even though they're very, very benign, can damage soil flora and fauna if used in large quantities. Same thing is true with raw manures, so we use compost. We do not practice substitution organic because we don't believe in doing that. We want to try to do it as sustainably and as naturally as possible. And we do that by primarily a designer cover crop mix. That sounds kind of weird, but that's very important for us as part of the entire system, because it attracts beneficial insect predators. Those pollen and flower nectar helps the predators stay here and not go away for food. And then the same thing is true for their habitat, their place that they're going to live and have their next generation of predators that will help us with our pest problems. We fertilize, like I said, with a cover crop and compost, and rather than synthetic fertilizer. And it's important to note that due to the fact that a lot of this has been replaced with synthetic fertilizer, ag soils have lost about 50 to 70% of their soil carbon in the last number of decades. And cover crops and compost and other biomass shown to really substantially increase soil organic material and therefore soil carbon sequestration as well. We use about 6 tons of, currently we're using yard waste compost. It's important to note that we do not till, and because tillage has been known to reduce soil organic material and therefore soil carbon, by just one tillage can reduce it by 27%. Additionally, the byproduct of the biomass is char ash, and that will sequester, and we'll talk about that even more in the future, in a little bit, carbon and nitrogen. And since synthetic fertilizers are, many of them are produced from natural gas, which is methane, therefore we use less, fuel and less methane from fossil fuel. Irrigation, this may sound like a funny thing to talk about for an energy thing, but again, in California, agriculture uses a tremendous amount of electricity for, well, fuel in general, energy in general for pumping water and irrigating, and so it's an important part of the equation. We do this with a kind of a novel through the tree branches hoses, drop sprinklers that we stole from the greenhouse people, and then it basically has a very high water efficiency compared to buried drip, and we can actually vary the number of valves to match the pump output rather than using VFDs. And it's all renewable energy powered, and the low pressure requirements for the system saves energy as well. The reason why I say VFD, by the way, is because most people don't realize that VFDs actually waste about 7% of the electricity going into them just to make them so that they can vary the speed of the motor. And they're very good for many applications, but they may not be the best way of doing everything. So here's the way it looks as far as the irrigation system. This is our orchard and the sprinklers in the cover crop. Cover crop practices, as I said earlier, it's a designer kind of a mixture. We do this to try to take up excess nitrogen, but we also produce nitrogen through the lagoons that fix atmospheric nitrogen. And then the soil organic material that is the result of this sequesters carbon, and it also takes up excess nitrogen, slows methane and nutrient release into the soil or into the groundwater. And we can actually save water by growing a cover crop in the winter time when our evapotranspiration is very, very low, and this actually can trap water in the summertime. That does that by basically surface, it puts a mulch on top of the soil, and it's been shown to save up to 20% of the irrigation water in the summertime. And we do have to disc it lightly to start the cover crop, but the consequences is that we actually increase the water holding capacity. We reduce water runoff too. The next 2 slides will show just what this looks like. This is not our orchard, but this is an orchard down the road that they try to control all of the cover crop, and the resultant runoff from a small rainfall incident looks like this. And I want to point out the sediment loads coming out of that ditch, and that's going directly into a local creek, as opposed to us, which this is our same day, same storm, and you see 0 water running off. We set a renewable goal in 2007 to become self-sufficient with using renewable power by 2012, while also trying to do all of the 5 things that I listed here, and I'm not going to read them off, but these are critically important. I did not want to take food sources for energy, and we wanted to make sure that the technology that we employed was transferable to others. One of the things we did was to go to solar, photovoltaic panels. We have a relatively small array, 17 kW, And it does all of these things that are shown here. We actually have, on all of our new buildings, designed them to take solar panels. And we can increase them up from the 3,500 square feet to 160,000 square feet if we can do this. And I'll talk to you about why we can't do this at this point in time. But one of the things is the solar cooling that occurs by the shading of roof panels. We make sure that we're doing it on a roof as opposed to taking land out of production. And the solar is a perfect fit with the freezer energy use in the biomass. And the biomass supplies the base load that we have for our processing facility and our pumps. And then the solar will take care of the peak power. We did this by using PPAs, and so we have no capital invested in the solar system. The other thing we did was the Biomax 100, as he was talking about earlier. It's manufactured by the Community Power Corporation, or CPC. That first one, the 50, was actually a California Energy Commission grant that they got and they put here. We have graduated from that to the next generation, and these are called the Biomax 100s. We have 2 generators on site of 2 100 generators, and they produce up to 250 kilowatts, or as he said, about 1.5 million kilowatt hours per year. And that offsets about $221 or so thousand of electricity per year. Additionally, the beauty about this particular system is that it produces a gas that we can use as a replacement for propane during our drying season. We dry walnuts, of course, and we also produce another byproduct of hot air that also we use right now for offsetting propane during the drying season. And then in the wintertime, we can heat our buildings with that. It produces hot water as well that we use for building heat. 100% of the energy is used on site, so there's not any transportation costs or anything of that sort. We use about 3.2 million pounds of biomass, in our case walnut shells, per year. And it's similar to the PPA. We have an ESA with CPC, so we don't actually own and have that money invested into the machinery. The environmental impact is, and this is critically important to me, because so much of the time we put PV panels on top of soil that's invaluable. This is on top of the roofs, and we use walnut shells, which are a renewable non-food source. The carbon cycle is really important. We use atmospheric carbon dioxide absorbed by the trees, very natural, produces walnut, which produces food, and shells for energy production. The energy used is used for drying, for irrigation, and for processing the walnuts and to maintain the freezers that we have. The char ash byproduct is about 5% from the biomass as carbon, and then when we put that into the soil, therefore we become carbon negative. We actually are sequestering carbon in very, very long-term increments, up to at least 1,000 years. Some people say 2,000 or 3,000 years that the carbon is sequestered in the soil. In addition to that, this particular type of biochar or char ash has a very high cation exchange property, and so it ties up excess nitrogen and uses less water and reduces NOx emissions. And again, you'll see that there are some studies that are highlighted here. And these are all studies that have been completed on our property showing what I'm saying. Here's what the walnut shells look like. Here's the actual, one of the actual Biomax 100s. The hopper where the shells go into, and another side of the Biomax 100. Very small footprint. And then another shot of another side of the Biomax 100. The impediments that we have to using the biomass the way we are using it is, one, the Air Pollution Control District is, and I don't want to say bad things about them in the sense that this is actually a federal law that they're having to administer, but the regulations and fees are extremely high for using biomass, because instead of using a fossil fuel, which is kind of tried and true and simple, we have a special product that we use, and as you can see that the cost of that is quite high compared to what we would do if we had propane. But it's not due to the emissions, because we actually are less than 40 parts per million of NOx, which is about half of what your car is putting out. So we need to treat emissions differently from renewable energy. The other thing is the char ash soil application, and you can see the whole litany of agencies that we had to go through in order to apply the char ash to the soil. And it needs to be understood that this is a totally non-toxic soil amendment, and we need to simplify that. And probably one of the biggest things we ran into is actually getting interconnected and then making that interconnection as useful as possible. And Senator Lois Wolk introduced SB 49 to allow us to get interconnected as though we were a solar or a wind facility under net metering. And then we need now to, she also introduced SB 594, which allows us to transfer that energy that's produced from one meter to another. The biggest problem is that we cannot transfer to non-contiguous meters, and so which is on different properties. And of course, agriculture, we have many properties scattered over, various areas. So we need to get that changed. Status report, as we talked about, is between the photovoltaic and the two BM100s. Is that I'll just read the bottom line here. The total reduction is about $400,000 of energy produced that would be produced by fossil fuels. We supply 100% of our processing energy and about 50% of our farming energy that we need. It's important everybody thinks this is free, but it's not, because we have to obviously maintain and work on the various infrastructure to get this working here. But we are offsetting all of this fossil fuel generated energy by using renewable power and on-farm renewable power. The costs are actually less than the current retail price of electricity and propane, and that is not including the Air Pollution Control District fees and PG&E fees. If we had to pay those, then it would actually, we do pay the APCD, but if we had to do the PG&E fees the way they wanted it to do it, it would not be cost effective, but it is under the current situation under SB 495 and 594. Return on investment is about 7 years, or 15%, and it may be revenue generating if we can get the greenhouse reduction market to actually fund some of those kind of reductions. The important part is we already exceed the 2030 RPS goals of 40% renewable energy. And so therefore, all of the processing side, most of the farm is net energy self-sufficient and greenhouse gas negative. If we get those changes that I've talked about earlier, we could actually be about 100% renewable and greenhouse gas negative. Our future projects is SB 594. I've already talked about that a little bit. The walnut oil, we produce a non-edible walnut oil that could be used for replacement for diesel fuel. Emissions reduction, we want to do some additional combined heat and power use. We want to increase our solar panels on the roof, possibly up to 160,000 square feet. And we can't do that now because we are already producing too much energy, and we cannot transfer that energy to our other meters. Perhaps another Biomax 100. We've sponsored all of those studies that are listed down below. And if we do this, as I said, our entire business will be net energy self-sufficient and further greenhouse gas negative. The conclusion is that cover crops can actually do a wonderful thing for a lot of greenhouse gas reduction, rainfall retention, water retention, cleaning up the water that comes onto our property. It increases the soil health and soil organic material. Char ash is also an excellent soil amendment. It has activated charcoal characteristics, which is like water purification, water retention, and nitrogen retention, and obviously carbon sequestration. And the important thing is to think about, we got to conserve as much as we possibly can, and that is a good thing for efficiency. Final thing is we've done all these studies, and we know that this works. We can do this now. We can implement this immediately. We just simply have to get those few impediments out of the way so that we can do this in a bigger way. And a lot of farms can do exactly what we've been doing and do it today. And the biggest thing is to say that all these climate change and greenhouse gas reduction goals can be met today, and agriculture can play a huge role in doing those kinds of goal setting and reduction. So I thank you very much.
Excellent. Thank you very much, Russ. Excellent presentation. I'm now very pleased to introduce Daryl. Daryl is going to be discussing more about Moss Energy Works Lagoon Digester, located at the Van Warmerdam Dairy here in California. Daryl, the floor is now yours.
Wonderful. Thank you very much. Well, hello, everyone. I'm going to describe some different uses of agricultural methane on some projects that our company, Moss Energy Works, has built over the past few years. We are a developer, owner, and operator of on-farm anaerobic manure digestion facilities. So these are some locations where we've built projects that either we own or in many cases, particularly in California, the dairy farmer owns, and we have developed and or managed the project for the dairy farmer to make that project work for them. You can see there's a pretty heavy concentration in the Central Valley of California. What does a manure digester look like, or what is a digester? I'm assuming a lot of the people on the call are familiar. But basically, it's a process for transforming manure waste into energy. And normally what happens on a dairy farm is the farmer already is using the manure in what we would call a closed loop. You can see that on the drawing there, that the cows produce milk, which is the cash crop for the dairy farm. They also produce manure, and that manure is stored in a large lagoon. It is spread on the fields. On the fields, it makes the crops grow, and the crops in turn feed the cows. And so this is a virtuous cycle, but it does have some negative products. The storage of manure in a lagoon creates a lot of methane, and the spreading of manure on fields creates odor as well. So what a digester does, at least the kind of digesters we do, is we try to plug into that existing nutrient loop on the dairy. We try to leave the dairy as unchanged as possible, but just collect some benefits from what they're already doing. So in the diagram here, what we've done is we've inserted a digester between the cows and the long-term storage of the manure. So you see here that we're still producing milk, and the manure is still going to be used on the fields, but first it's going to pass through a digester to produce various products, the two of which are most important to us is a biogas energy, which has a variety of uses, and methane offsets or carbon credits. The amount of energy we can get out of one cow's manure over the course of a year is about equal to 5 barrels of oil. That's the BTU equivalent in terms of the energy of biogas that comes off of a cow. And we get additional carbon credit reductions, which, as many of you know, in the case of a manure digester, you kind of get a double counting of carbon benefits, because not only are you generating electricity, which has a certain carbon benefit by offsetting conventional sources of power, but you also happen to be destroying methane in and of itself. So that is another reduction of greenhouse gases, because the fuel we're burning is a greenhouse gas itself, and we're capturing that methane that would otherwise be escaping into the atmosphere. What can you do with the biogas once you get it? The renewable industry often looks really cute and clean, but most of the time what we do is we put it in an old-fashioned internal combustion engine, and we make that into power. And that market is becoming much more robust. There are a lot of different national and international vendors selling engines to convert our biogas into energy, into electricity, although I will describe some other options a little later in the presentation. Different types of digesters we use. The simplest kind, the kind we use in California, is what's called a covered lagoon manure digester. This can be a new pond or an existing pond on the dairy, and the installation is really quite simple. You see here an existing dirt pond. This is in Sacramento County, not far from where the conference will be. And all we're doing here is we're putting a perimeter pipe around the outside to help us collect gas, and then we're going to lay a cover over the top of that pond, and we're going to bury the cover in the trench you see there to create a gas seal. So when it's all done, it looks something like that, and that will enable us to capture all the gas that previously was being created in this pond, but it was just evaporating up into the air. Here's another covered lagoon. just kind of showing the three pieces and how simple these can really be. This is the Van Warmerdam project, which is also in Sacramento County near Gulf. In this case, it's about 1,000 cows on the dairy, and those 1,000 cows can supply our engine with enough fuel to run 600 kilowatts. Now, we run that one on a peaking cycle. One of the other things that's great about covered lagoon digesters is they can store gas overnight. And so we allow the gas to build up at night, and then during the day we turn on the motor, we generate our power, we use up all the gas under that cover, and we shut the motor off again. You see there's kind of a container there, and that's just a 40-foot modified shipping container and a transformer and a power pole. So in that one picture right there, you see all the components we need to build a relatively efficient small to medium-sized dairy digester in California. Our smallest ones in California are 250 kilowatts, and our largest ones, which are under construction now, will be about 3 megawatts. So that is the range of power production you can see on a California dairy. Now, in some of the colder climates, you can build different digesters. This is called a mixed plug flow digester. This particular one is in north of Seattle, Washington. But in that environment, you have to insulate the digester. So you see in this model, that's the digester under construction on the top right-hand corner. And there's some heat exchangers inside the tank there. And then we're going to put a lid on the top. And you see the yellow insulation all around the sides to try to keep the heat in the digester. So that's obviously a much more expensive proposition, but the same kind of technology is happening. All a digester is doing, whatever design you use, is it's trying to simulate a cow's stomach. It's trying to take the bacteria in the manure and keep them warm and in an airtight environment, and they think they're still in a cow, and they just keep on eating calories and producing methane gas. That's what these look like on the inside when they're all done. A little more complicated, and no one will ever go in there again. That's the last picture probably ever taken inside of this digester. Other things you can do with the energy is a lot of times you have waste heat. This is a facility in Washington where we are set up to heat a greenhouse using just radiant floor and overhead hot water heating. So as the gentleman who spoke before me said, there's a lot of uses of waste heat or hot water, or in some cases steam from biogas, and those are all good uses of methane. Here's another type of digester. This one's in Oregon. Same kind of thing. We're putting a cover over a large pond to capture the gas, and there's all the gas coming up underneath it. I was asked to speak more specifically, although I'm happy to take questions about digesters in general. I was asked to speak more specifically about California and the various policies as they relate at least to our portion of the methane world, which is the dairy digester world. So I'll go over a few of those here, and then I'll wrap up my presentation. We deal with at least 4 major regulatory agencies, and I'm sure some of them are on the phone here today, so I'll keep my comments as professional as I can. We have, first of all, the Air Resources Board. Now, what's interesting about the Air Resources Board is they manage a bunch of different programs, which I will mention in a bit. But as far as just strictly regulation, which is the authority to construct program and basically the permitting process, the Air Board is not as big of an obstacle as some people make it out to be for the digester industry. We have very strict standards in the San Joaquin Valley. We have to install a lot of equipment. I have lots of permits on my desk with lots of requirements in them. But at the end of the day, we can comply. The biogas industry is capable of meeting the standards that the Air Resources Board has put on our engines. And although it certainly adds cost and overhead and hassle, it is something we can do, and it doesn't significantly stop us from building these projects. So as far as just regulations, you know, it's tough, but the Central Valley is tough. There are real air quality concerns there, and so we do our best to help address those. The second major regulator we deal with is the regional water boards, and those apply especially to the storage of manure and the transporting of manure and the application of manure onto the ground. If you want to build a new digester in California, you have to bring whatever type of digester you're building, it has to be brought up to the latest standards of the regional water boards, and those can get pretty expensive. For example, if you build a new manure pond in California, it needs to be double lined with plastic liners, and then a geonet in between the liners, and then some leak detection, and then usually some monitoring wells. So that is a pretty significant barrier for for a lot of farms, unless they're very large and they really, really want to expand, and therefore they need to build a new facility that's going to be permitted up to the latest levels, they can usually do it, but most farms have a very hard time meeting the Water Quality Board requirements for building new structures, and that is constantly an issue for us. Once again, we can deliver projects that are in compliance, obviously, but the cost, especially on the front end, the capital cost is pretty significant. So what that tends to do in California is it pushes up the average project size, where it's only the larger dairies that are able to take this on. The two smaller ones I discussed in Sacramento County, they were only able to do that because SMUD, the local utility, provided a lot of funding. And most digesters are similar. If there's some public funding available to help them get over that regulatory cost, then they can do it. But without public funding, it's pretty hard. Moving down the table of regulations there, we have CEQA, which is not really any one agency, but it's the California Environmental Quality Act. And that can really be a burden as well, particularly if you're doing anything out of the ordinary. So if you want to build a digester on a dairy that's already permitted and you're changing nothing, then CEQA isn't too much of a problem. But if you want to build a new digester where there wasn't one a dairy before, or if you want to digest food waste or other organics, or if you want to do anything out of the ordinary, the CEQA process is a huge, huge speed bump, and not just for us, but for large chunks of California construction process. And that's not any one regulator, but it is basically something that pushes us towards trying to stay, how can I say this, limited in scope. If you do something too aggressive, you expose yourself to all kinds of CEQA opposition, either from the government or even from private parties that are using CEQA as a method to obstruct construction. And so it makes it hard to undertake large or complicated digester projects, especially if they have water and air quality impacts. And finally, the Public Utilities Commission, which I'll talk about a little more, but the Public Utilities Commission controls, for us, the rates for power in some ways, and the process of connecting to the grid. And I won't get into that a lot, other than to say that the process is pretty fair for connecting to the grid in California, but it's very slow and it's very expensive. And so it just slows down these processes. But overall, it's fair and well administered, is my opinion. Okay, a couple of the funding items on when you look to see if a project in California is going to be successful. We have something called the Bioenergy Feed-in Tariff. This is a new contract as of last year that pays a pretty good price, a modest price, for selling power to the grid. And most projects, this is the method they choose because it allows you to get a long-term 10 or 20-year contract to sell power. So you can go out and get a loan, you have a contract, you have a guaranteed source of revenue, and for most farmers, that's the risk profile they want. They want to know what their price is, they want to know what the terms of their contract are, and even though, as I say in the slide there, even though it's expensive and slow to apply for this tariff, and even though it takes time and money, that is the model that's been proven to work in just about every digester in California. This is the model they've used over the past 5 years. That doesn't mean others aren't possible, but this is the one people use. Maybe not this tariff, but other similar tariffs or ways of selling power. Now, we have another source of revenue. Usually the second largest source of revenue on a dairy digester is the sale of carbon credits. And we have a process in California called the AB 32 cap and trade system, which is run by the Air Resources Board. And that's been pretty successful from the digester's point of view. Up until AB 32, we had to sell carbon credits into voluntary markets, which were hard to predict, and the prices were a little lower. AB 32 and ARB's use of it has created a mandatory market that we can sell carbon credits into. And so we produce these credits, we sell them to regulated parties under AB 32, and that provides a long-term steady source of revenue that enables us to leverage private financing, be it investors or banks, to build digesters, and that works. There's a couple problems with it. First of all, nobody knows what's going to happen with the program post-2020. And second of all, there are other programs and government policies that kind of get in the way of our current model. That'll be on a later slide. Nearly done here. We also have some other things administered by ARB. There's something called the Short-Lived Climate Pollutants Plan, and the largest of the short-lived climate pollutants is methane, which is the topic of the webinar. And one of the goals of this plan was to try to reduce agricultural methane emissions by 75%. To do that, you would need 500 digesters. And the plan is pretty good in that it recognizes that digesters are effective at reducing short-lived climate pollutants. It has some other recommendations of practices that are not as effective, but it does recognize digesters, and we appreciate that. One of the main things we think about digesters that makes them great is they self-fund. They create their own revenue, so they're a great way of reducing short-lived climate pollutants. One of the issues we have is if this policy ends up in a state mandate for digesters, if they become required, well, then you can't sell carbon credits anymore, because carbon credits are only valuable if they're over and above your regulatory requirements. So if, in fact, the Air Resources Board begins requiring them, then all of those of us who are selling carbon credits will have the carbon credits will go away from our existing digesters at the end of a period of time, probably 5 or 10 years, and all new digesters won't be able to sell carbon credits. So that basically drives up any private financing based on carbon credits, and it forces these projects to go look for public finance. Finally, there is something here called the Low Carbon Fuel Standard, which is another Air Resources Board program, which is trying to incentivize more production of transportation fuels, of vehicle fuels. And many of us in the digester community are trying to find ways to sell into that market, because there's a very high potential revenue for selling biogas as a vehicle fuel. But there's a few difficulties. First of all, it's hard to sell vehicle fuel on a 10 or a 20-year contract, so there's a large counterparty risk there, there's a large price risk. And once again, this program is kind of uncertain after about 5 or so years. So to invest a ton of money now into a project that entirely depends on a regulatory program that may go away and that you can't sell into long-term revenue, it's just a heavy lift. So it's hard to build a project without a tremendous amount of at-risk capital that could take advantage of this. To try to sell, say, compressed natural gas or pipeline injection gas into this market is very expensive and complicated. But hopefully one of us will figure it out, because it would be exciting to see. There is one program out there that the state is offering right now on a routine basis to fund digesters. There is other funding available from CEC on every once in a while on a non-recurring basis, but just recently, the California Department of Food and Ag started a new program which last year had $11 million to fund the development of digesters, which was quite generous, and it did award 5 digesters, of which at least 3 will be running, I think, by the end of the year. And so it's done very well. This year it has a request in for $35 million, which would be very helpful to the industry and would help more of these get built. So that is another good development for digesters in California. And that is the end of my slides. Thank you very much.
Excellent. Thanks, Daryl. Terrific. Very, very informative. At this time, we're going to transition to the question and answer portion of our webinar. Thanks to all of the attendees who have so far submitted a list of really terrific questions. Just want to remind everybody that if you do have a question, please submit it by using the Q&A portion at the lower right hand of your screen. With that, I think I'll toss the first question, Ross, in your direction. Just a real, could you recap for us? I don't know that you went into any significant detail in your presentation. How precisely does that biomass system that you're utilizing there, how does that work?
So it's actually something probably everybody has seen. Basically, if you take cellulosic material and heat it to very high temperatures, approximately 2,000 degrees centigrade, it outgasses methane, hydrogen, and carbon monoxide. And so what this does on our the Biomax 100 system actually does is it burns in an aerobic environment the walnut shells to produce a very, very high temperature. It burns about 10 to 15% of the walnut shells going in there. And then the rest of the 90% of the shells that are left are subjected to this very, very high temperature under anaerobic, without oxygen conditions, which causes this outgassing of the gas, the combustible gases, as well as the biochar, as well as heat. And then we actually clean up that gas, filter it so that the carbon and the biochar is removed, recool it, which is where the hot air comes from, and then we use the combustible gas in an internal combustion engine to generate electricity. So you've all seen it. You've taken a log and thrown it into a very hot fire, and you'll see that little jets of flame are coming out the side, and that's the same thing we're burning.
So Russ, is your system considered a gasification system, or is it considered a pyrolysis system?
Well, it's called pyrolytic gasification, so I guess it's a little bit of both. And so it's used in high heat to actually gasify the cellulosic material into those components.
And how is that different than a traditional biomass plant that we're used to in California?
So a traditional biomass plant, number one, has typically higher pollution levels from this process. As I said, we're actually relatively low, especially in NOx emissions. The other thing is that they're using oxygen to do the complete combustion and producing heat only. That heat is then used to generate steam, which is then going through a turbine. That's typically what happens. We're using the gas to actually produce that energy in an internal combustion engine. The outcome is instead of ash, which actually isn't necessarily a positive thing for a farm to put into the soil, we're producing this biochar, which actually is. The other thing is because it's ash, almost all the carbon is going back into the atmosphere, and so it's not as negative of greenhouse gas and carbon, whereas in our case, approximately 5% of the carbon that comes into the plant is put into this biochar, which is very, very stable, long-term carbon sequestration, and can be added to the soil as actually a positive amendment for the soil.
Thank you. Daryl, quick question for you. Could you give us a sense of the length of time that it takes to develop a new manure digester project in California? Can you give us a sense of what are the longest lead time items or activities in that effort?
Sure. So if we're talking about a dairy digester that's going to connect to the utility grid and supply power, which is the predominant model right now, it takes about 20 to 24 months from start to finish, from your first applications to actually creating power. And the longest lead item there is that grid interconnection. There's a long process of studying the connection to the grid, and then once the study is approved, of installing the necessary improvements. So that is mainly our largest item for how long it takes to get these in the ground. The actual construction of the digester, including the air permits and the water permits, wouldn't have to take more than 6 or 8 months if it didn't rely on the power grid.
I guess a correlation or an extension of that question is, do all of your projects apparently generate electricity from your gas? Do you have any projects, or are you contemplating any projects where you're actually going to be injecting methane into the natural gas grid? Daryl? Okay, well, maybe Daryl is on mute or can't hear us. So Russ, I'm going to go back to you. Question, how do you clean up the biogas to ensure the reliability of your electrical generator? Do you see any sort of significant differences in biogas composition?
Yeah, we do. We have at least 2 reasons to clean up the biogas. One is we want to protect the generator, and 2, there's an air district requirement to keep the sulfur in particular very low. And so we use a 2-stage process. It's called biological fixation, where we actually inject a small amount of air back into certain parts of the digester, and we try to encourage some bacteria that eat sulfur, and they will actually fixate a lot of it right there in the cover. They kind of build a crust in the manure. And that will reduce it a certain amount, but in order to guarantee it's going to get down, we usually have to do an additional media-based scrubber, whether an iron sponge or an activated carbon scrubber, to get the sulfur out of the gas. As far as the rest of the gas quality, digesters can be pretty variable in the methane content and the CO2 content, and we don't really control for that. We just build a system that can tolerate a lot of changes, and that's one of the reasons that we really like our piston engines. There are fuel cells on the market, there are microturbines on the market, but every time someone tries to run them on dairy digester gas, it kind of crashes and burns. Very hard to get those systems to perform on variable quality gas.
So I'll ask. I know that we have Daryl back, but Russ, I'll ask you the same question that I'm going to ask him, and that is, have you ever contemplated, or do you contemplate in the future delivering gas to the gas grid?
No, and the reason why, and actually we don't store it, it's a little bit different than Daryl's project, the digesters. We actually do not store the gas. We produce and use the gas as we go along. And the reason why is because it's a relatively low-grade gas, and injecting it into the gas grid, if you will. First of all, we don't have that available to us out on the farm. And then secondly, it would be not probably something that the gas people would want, because it's relatively low BTU gas. But it is able to be used in like an internal combustion engine, like I was talking about, pretty much straight in. It doesn't have to be mixed with oxygen. It's pretty much the same. And then as far as the previous question, as far as cleaning up the gas, the main problem we have to clean out of it is the biochar, because it's roughly 50% carbon that would actually just totally destroy the engine in a very short time by wear and tear. So it's this filtration from that to remove the biochar. And then as far as the gas itself is concerned, goes through the generator straight. It's a relatively clean gas, and then it has catalytic converters, just like most engines do, to reduce the NOx emissions.
Daryl, back to you. Same question. You mentioned in your presentation about LCFS credits. LCFS credits, of course, only work if you deliver that gas to a transportation user. Do you have any plans to deliver gas to the grid or directly to a transportation user?
We have some projects that I would say are in the planning stages to do that. As I mentioned in my presentation, the potential revenue from that is much higher than you can get with electricity, but the logistics are very difficult. Probably the easiest way to do it would be to connect and build your own compressed natural gas fueling station, which can be done, although the revenue model is interesting. You don't know for sure what price you're going to get, and you also have to scrub the gas of CO2, which is complicated. The pipeline injection is even more complicated, because you need to be located near a pipeline, and getting permission to pump into the pipeline and then meeting all the standards necessary would require a huge project to cover those costs. In fact, this has only ever been done once in California, and it went very poorly. It operated for a year or two and went bankrupt back in Fresno County about 5 years ago. So we're all looking at it. We all would like to. We all can see the benefit. It's just finding the model and knowing that it will work, and somebody to put all that money at risk to do it is hard, particularly when the LCFS program is going to go away in 5 years. Of course, maybe it won't. Maybe it'll stick around, but it's a hard investment to make.
Understood. But particularly with dairy gas, given some of the projected preliminary pathways, the revenue stream is at today's LCFS prices is enormously attractive. Although, of course, there's still great uncertainty. It's a market, so we don't really know where those LCFS prices are going to go in the future.
Yeah, you're right. The LCFS prices certainly look attractive, and there are others in the industry that are probably more bullish on this than I am, that are trying to find a way to sell into that market, and I would love to see it happen. I do have a couple projects where we're trying to make it happen. It's just it's less of a sure thing, and I hope someone will pull it off. Hopefully me, hopefully one of my competitors. We would love to see that happen.
So
Russ.
kind of, if I can chime in a little bit on that
please,
same question. One thing we're looking at is we're converting more and more of our machinery, the forklifts and, various other equipment into electrically driven ones that can be. And so that's the kind of storage that we're looking for, is actually electricity storage and utilization better. As far as the liquid fuels are concerned, I put it in my presentation. I didn't really talk about it too much. But, we have the walnut oil byproduct that actually could be a substitute, direct substitute, for diesel in all of our diesel engines. And we're actually looking forward to that. We haven't done it yet. It's been done. So it's not a novel technology. It's just that we haven't had a chance to actually put the presses in and get it going. So, but I think that actually we can power about, I think estimated at least 50 to 75% of our diesel fuel usage on the entire farm by using this non-edible byproduct of our processing.
Do you produce that walnut oil now, or would you have to create the process in order to produce it?
We create the oil now. It's a non-edible product. We still sell it, and people make an edible product out of it, which is highly power consumptive as well. What we have to do is to actually buy and install the presses to press the oil out of the oil stock and the filters and such like that to do that. But the beauty about walnut oil is, unlike corn oil, it actually does not need to be esterified to turn into a combustible fuel. It actually can go straight into a diesel engine.
Thank you very much. One of the questions that one of our listeners submitted, Daryl, was if you know of any digester sites producing CNG fuel right now. You mentioned just a moment ago that you knew of only one that was in Fresno and that it failed. Do you have any more information about that you could provide us?
Sure. To my knowledge, there are 2 digesters in the United States that are currently making CNG. One of them is in Fair Oaks, Indiana, which is a fairly large facility, kind of with a visitor center and all kinds of stuff, kind of showcasing technology. There's another one supplying a small amount of CNG near Tulare. It's a very old facility, and they basically do it just for their own milk trucks. And they've been doing that 10 or 12 years at an existing digester. The one I was describing was originally called the Vintage Dairy Digester. It was in southwest Fresno County, and they were attempting to inject biogas into the utility pipeline. So they were going to be a pipeline injection project, the only one that I'm aware of that ever attempted that on a dairy in California. And they had trouble meeting the quality requirements that the utility wanted. They had a variety of operational issues. Then the price of natural gas went against them. This was in 2009 when the price of natural gas collapsed. So there was a variety of issues, and they shut that facility down.
Do you happen to recall which utility they were working with to try and make that work?
Oh, that's in PG&E, and if you want to Google PG&E Vintage Dairy Digester, there's still some press releases talking about the great potential of the project, but it didn't work out for them the first time. That doesn't mean it can't be done again. I think at the time also there was not some of the incentives that are currently available now, and although they had mechanical and logistical problems, I think certainly the financial incentives may have helped them if they had been around back then.
Thank you. Russ, Daryl showed us the genset that they use there at the Van Warderdam farms. What sort of genset do you use?
Well, in one of those containers, it's a lot of these guys like Daryl's, use these containers to actually house the generator itself to protect it from the weather and such. Inside one of those containers are 2 basically propane engines. They're General Motor engines that are modified to run on this what's called producer gas that I talked about earlier, and so they put 2 in there just to have sort of a redundancy, so that one can operate at pretty much all times. And so we have 4 of those generators on site, but basically it's a propane GM engine powering a generator.
Excellent. Thank you very much. And thanks to both Russ and Daryl for 2 outstanding presentations today. Unfortunately, we're out of time. Sorry we didn't get to all the really great questions that were submitted by our audience. I'd like to thank both Russ and Daryl for devoting their time to the Rethink webinar series today. 2 outstanding projects that serve as models for others who are pursuing these sorts of activities in the state of California. Feel free to contact any of us or even myself for any questions that you might have. We want to make sure that everyone, all of our participants, continue their education. Please join us at the Rethink Methane Symposium on June 29th and 30th in Sacramento at the Sacramento Sheraton. The agenda for the 2016 event is online. You see the information basically in front of you. If you just Google Rethink Methane, it'll take you to our website. As a reminder, this webinar was recorded today. It'll be available for replay via the email link that we're going to send to everybody in a few days. Again, thank you very much for joining us, and we'll see you in Sacramento.